So to start off, we got this without using a calculator for each pair to determine which fraction is bigger, and we'll justify the answer right again. Alright, so if you have one of something, you want a smaller denominator, which will give you something bigger in this case. So 1/9 is bigger than 1/10 in this case. Alright, so for part B, this is just going the other direction now, because now you have one less of a tenth and then one less of a ninth, so we're missing more out of the ninths, meaning we have more tenths right here. Alright, so C, you can either have 5/9 or 5/11. Alright, 5/9, one way to look at this is 4.5 is half of the 9, and 5 is more than that. 5 is less than half of the 11, so more than a half would be the bigger of the two. Alright, so you could either have 5/12 or 5/14. Well, if that were the case, hopefully you'd choose 5/12, unless it were something bad. So 5/12 is bigger than 5/14, because 14ths are smaller units. The bag of marbles contains 3 red marbles, 5 of the others, and 2 yellers. So if we look at these, we want the probability of red to start out, and the probability of red would be 3 marbles that are red out of 10 total marbles. So of this other even color, there is 5 of those colored marbles out of the 10 total. And if you had simplified this to 1/2, that's okay as well. Next up is Old Yeller. There's 2 yellers out of 10 total marbles. And again, if you simplify it, that's okay, 1/5. Now, the other thing about these is they had said it at the beginning, they want the decimal and the percentage for these. So we're just going to change those into decimals. Multiply the decimal by 100, and that tells you by what the percentage is: 30, 50, and 20 percentages. So what is the most likely outcome when drawing a marble out the bag? That'd be the probability of pulling out some perverted purples. What is the least likely outcome when drawing the marble out the bag? Well, the lowest percentage one we have is Old Yeller. Alright, have you been computing theoretical or experimental probabilities? This one would clearly be theoreticals. Yeah, so it's theoreticals because we actually didn't do anything. We just found the marbles that were inside the bag. We didn't actually put them in a bag and pull them out. So those are simply theoreticals. A spinner contains 3 letters of the alphabet. How many outcomes are possible if the spinner is spun 3 times? Well, it may be helpful for us to do B first, because it asks for all the outcomes first on B, which would then tell us how many outcomes there be. Okay, so let's get started listing all of these. So the first one I'm going to show up here is if I had spun a K, and then I spun on the second spin a K, and then on the third spin perhaps I spun a K. Well, what about the second time? Well, the second time I go up I spin a K, maybe the second one's a K, but now I'm going to spin a V. Yeah. Well, what about the next one? Well, if I spin a K, and then a K, and then maybe an H. Alright. Alright, next up is if I spin a K first, then perhaps I spin a V next, and then another K. Or I can spin a K, then a V, then a V, or a K, then a V, then an H. But I could also spin a K, an H, and a K, or a K, an H, a V, or a K, an H, and an H. Now that's with a K on the first spin each time, right here. And right there we have 9 to start out with. But that's only when spinning a K foist. Well, what if I spun maybe perhaps a V foist? Well, then we should have these other options. It's pretty much going to repeat, but now the V is in the front. Bam! And right there we have 9 more from spinning a V the first. And then finally is perhaps if we had spun an H on the first spin. Then we also need perhaps a K and then another K and the rest. So there we go. This is all of them that we have. And if we counted these, we would find that we would have 27 up in count. So that's listing all of them. Then what is the probability of getting exactly one H in 3 spins? So let's look. I've got one H right here in this set. And I've got one H right here. 1, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. That's what I got. So exactly one H in 3 spins, we said 12, and out of 27 total outcomes, which we could simplify then by dividing both those by 3 to 4/9, which as a decimal is 0.4 repeating, or 44.4 repeating in percentages. Then what's the probability of getting 2 V's on 3 spins? Well, there will be 27 outcomes right here. Go ahead and count. Let's find them. There's 2 V's. 1, 2, 3, 4, 5, 6. I got 6. So 6 out of 27, which does simplify to be, oh wait, no, it'd be 2/9, which is the same as 0.2 repeating, which is the same as 22.2% repeating. What's the probability of getting the 3 Ks on 3 spins? Yeah, there's only one that has 3 Ks out of the 27, which has a decimal in percent. So if we wanted to show that the percentage repeats, we'll show the 703 repeating. And then that's in a percent right here. Place the fractions on the number line below. Okay. So 2/3 would be, if I split that up into thirds, should be right about right here. So that'd be 2/3. 3/10 would be right about right here. 3/10. 1/2 is right in the middle of 0 and 1, so there's a 1/2. Then we got 3/2, which would be right here, for 3/2. And then finally 4/3, which is a full 1, and then another third, which would be about right here, at 4/3. So now we should be able to list these from leastest to greatest. The leastest is the 3/10. The next leastest is the 1/2. We're just going from left to right on the number line.
Then 2/3.
Then 2/3.
Then 4/3.
Very good.
And 3.
There you go, 3/2. And we'll put commas between these to separate. All right, all this stuff should be pretty familiar from, I think it was Unit 5, working with percentages. So we need to change each of these fractions to a percent, which means that we're going to change these first to decimals and then change the decimal to a percent by multiplying the decimal by 100. On the other hand, though, this is 1 divided by 5, which would give you 0.2. And yes, calculators are okay right here. If I multiply that by 100, I would get 20% right here. So that's what we really wanted out of that, was the percentage. Next up, 9 divided by 10 is 0.9, which multiplying by 100 would give us 90, but that's a percent now. All right, 3 divided by 20, this one should be 0.15. Multiply that by 100, and you get your percentage, 15%. 2 divided by 5 on the calculator would be 0.4. Yeah, we'll multiply that by 100 to get 40%. All right, now they've given us percentages, which we need to change into fractions, and we'll simplify those down as far as we can go. So to start out, we got 60%. That means that would be 60 over 100. All percents are per hundredths. So 60 per 100, 60 divided by 100, which we can simplify both of these. Simplify both these by 20, then I get 3/5 as a fraction. So 80% is 80 per 100. And it looks like I can simplify both of these by 20 each. Me as a fraction simplified, 4/5. These ones are going to be the same idea. 75% is 75 per 100. And we can simplify both of these by a factor of 25. So divide both by 25 gives us 3/4. 10% would be 10 per 100. And yeah, some of you guys know you just cancel the zeros, which gives us 1/10. 9 is 5%, so per 100. And we can simplify both these by dividing by 5 on each, which gives us 1/20th. 25% is a common one, but we'll show the process still the same. So 25 per 100%, and we'll divide both these by 5, and that gives us 1/4. Solve each using a model and mental math. Actually, we're going to use a percent proportion on these. So just to review, the percent proportion starts with two fraction lines that are equal, and we always have 100 right account. The percent goes above the 100, and then we got the part, which we will then divide by the whole. The other way was to find the word is, which is the part, and of, which gives us the whole. So in this example, setting up the proportion, is we got the percentage at 40, right? And then it says of 40, so that's the whole. So this is where the 40 is. We just don't know what the part is. So using good old fish method, we got 4 values, and it's always multiply, divide, and equals. And drawing the fish, from the x we go down to 40. Then we'll bring it up to this 40 right account. Swing it back down to the 100. And it appears that this would give us x. So x, in this case, the unknown, which is the part, is 16. So the answer here is 16. All right, same idea on this one. We'll set up our percent proportion with 100 down here. This one did not give us the percent. It says of 240, so that's our denominator, and then is 60, so that's our numerator. And using good old fish method to solve these would give us 100 times 60 divided by 24, and that would give us our answer up in here. Yes, thank you. 240. That's better. So it appears that the answer is 25%. Next up, 15, same idea. Percent proportion, this one is 8%. And it says 40 is 8%. It says of what number? That's our unknown. So the 40 is right here. So we'll replace 40 right here. And using fish method, cross multiplication, doesn't matter which one you use, but the answer is 500. Next up is 60 is 30% of what number? This one's going to set up the same way. Out of 100, we do have the percent at 30. We just don't know of what number, so that's our unknown. And the 60 is. So we got this right here. Once again, using whatever method you like, solving at these. I would use Skelos factors in this case, and that would give me 200. So that would be our answer.